remember in college, I would have 10 minutes to get from one class to the other. And these classes were not just right next to each other. So imagine me speed walking down an icy hill, afraid at any minute I will just faceplant onto the ground because the college didn't put salt on the path. That was my Tuesdays and Thursdays for a couple of months. At times like these, I wish I could just press a button on a remote and open a wormhole leading to my desired location. Or maybe take a day trip to Pluto with the essentials so you know I survive. From a London double-decker bus traveling through a wormhole in Doctor Who, to Loki using the Tesseract to open portals allowing the Chitauri to invade New York, wormholes have become a popular feature in science fiction. Need to reach a faraway planet quickly? Use a wormhole. Need to reach Hong Kong before the ruler of the dark dimension absorbs our world into his so he can turn us into mindless ones? Use a wormhole. Wormholes are an easy way to explain how a character gets from one location to another in a short amount of time. Not to be mistaken for their dangerous cousin, the black hole. Wormholes describe a passage through space-time, creating a shortcut between two locations. It's a cool idea, but are wormholes real? I mean, the idea has to come from somewhere, and it does. Have you heard of Albert Einstein's theory of general relativity? Well, even if you don't know anything about it, here's a super brief explanation of general relativity. General relativity is really fascinating because it explains the geometry of space. Don't worry, there will not be any math in this explanation. Let me first define space-time. We think of the world as three-dimensional. You're 3D. This meerkat is 3D. What would you do if I told you there was a fourth dimension, and that this fourth dimension is time? That's space-time, the union of space and time. Space-time is hard to physically visualize, so just take Einstein's word for it. Now imagine a trampoline, which symbolizes space-time. Now place a heavy object in the middle, like a bowling ball. The trampoline will cave in towards the bowling ball. Now, if we placed a marble towards the outer edge of the trampoline, the marble will roll towards the heavy object and may even orbit it. This is a very simplified example of general relativity, but it explains the idea. But how does this relate to wormholes? Wormholes are actually predicted by general relativity, like how black holes were too. Imagine our trampoline from before, but this time folded. Kind of hard to visualize a folded trampoline, but just go with it. If there is a cave on both sides of the trampoline, you could technically connect them and bam, a wormhole. Seems possible, right? But why haven't we found one yet? While wormholes are solutions to Einstein's field equations, and they can theoretically be possible, there are reasons why we haven't found any. One reason is that wormholes are theoretically not stable. If a wormhole is formed, it would collapse almost immediately once any type of matter enters it, and may become a black hole. To stabilize a wormhole, we would need what has been called negative mass. Negative mass is exactly what it sounds like. Mass, but negative. Like -1 kilogram. Negative mass would have properties like accelerating in the opposite direction of gravitational force. Negative mass is possible in general relativity and may be the key to preventing wormholes from collapsing. However, such matter is theoretical. Though the Casimir effect does show that negative energy is possible, but that's a whole other rabbit hole to fall into. It has also been suggested that wormholes are microscopic, possibly measuring 10 to the negative 33 centimeters. To give you some perspective, the approximate atomic diameter of the element carbon is 2.2 times 10 to the negative 8 centimeters. If carbon can't fit into the wormhole, there's no way we will either. These wormholes, which are called primordial wormholes, are believed to have formed in the early universe from a group of particles popping in and out of existence. Researchers have found by using the Dirac equation, an equation that combines both quantum mechanics and relativity, they can mathematically prove that tiny traversable wormholes are possible. In their findings, negative mass is not needed. Matter which is small enough could pass through these tunnels. Further research needs to be done, of course, but it's an exciting notion to think that wormholes could be possible. Maybe we just need to look harder, since it's assumed that black holes and wormholes are indistinguishable. So how can we distinguish the two? Well, radiation might be the key to this. Black holes produce less gamma rays and eject them in a jet, but wormholes will confine these gamma rays in a sphere. This is based on the fact that matter coming from both openings of a wormhole would crash into each other and cause an explosion of gamma rays that could be observed with a telescope. Gamma rays are interesting because they come from some of the most extreme places in the universe, like black holes. The Fermi Gamma Ray Space Telescope is a NASA spacecraft that can observe gamma rays in the universe. Fermi sends the information back to Earth, where scientists can create a picture of these objects. However, more than half the data is a mystery. So maybe we are collecting data from wormholes, but just can't decipher it yet. I should also mention the Schwarzschild wormhole, because this wormhole consists of a black hole and a white hole. It should be noted that a white hole is purely theoretical, like almost everything else about a wormhole. While a black hole may allow stuff to enter and act like a hoarder by not letting go of that stuff, a white hole is more of a minimalist. White holes are thought to be impossible because it violates the second law of thermodynamics, which states that entropy can either remain the same or increase, never decrease. However, white holes decrease entropy. No wonder wormholes are so unstable. Can you imagine having a black hole and a white hole in the same room? Well, we probably wouldn't even have time to imagine it because we would be gone. Just gone. You know, before doing research on this subject, I actually believed wormholes could exist. But now, I'm a changed person. I'm much more skeptical of their existence. A lot of what makes a wormhole possible is theoretical. While I do believe wormholes are possible at the atomic level, I'm less convinced they can be any larger. But maybe I'm wrong. Black holes started out as just a theory by Albert Einstein, but then became fact in 1971, when the first one was discovered. This is why science is amazing. There never seems to be an end to what can be uncovered. Maybe as technology improves and more physics is discovered, we'll have an answer to whether wormholes actually exist. But for now, they will just have to live in science fiction and our imaginations. Thank you for watching and have a wonderful day.